So in this problem we will be dealing with the design problem, that is design of beam. I will be going through the simple problem. So problem is design is simply supported reinforced concrete rectangular beam whose center to center distance between support supports is 8 meter. It is supported on brick wall of 300 mm thickness. The beam is subjected to imposed load of 7 kN per meter. So that's the problem. Design is simply supported reinforced concrete rectangular beam with center to center distance between support is 8 meter, and it is supported on brick wall of 300 mm thickness. Now the beam is also subjected to imposed load of 7 kN per meter. So if we just saw the diagram, in that case you will get this is a beam. You have this center to center. This is actually brick wall, which is 300 mm thick. And you have this center to center distance, that is 8 meter. And you do have the imposed load of 7 kN per meter on that. And to design it, so we'll go one by one, step by step. First of all, let us have the solution. So let's start with the solution. Step number 1. That is grade of steel and concrete. So this is as per we'll going through the page number 15 and 20. So what does 15 page number says? So page number 15 says the clause 6.1.2, the minimum grade of the concrete for plain and reinforced concrete shall be as per table 5. So as per table number 5 we need to go. So if we just go this table number 5 here, which is on page number 20. So basically minimum grade of the concrete, if you just look at for the severe exposure condition, that is M20, while for the moderate exposure condition, that is M15, right? So we'll be going through the M20 grade of the concrete. So therefore, as per clause 6.1.2, page 15 and table 5, page 20. This is from IS 456 2000. So assume Fe 415 and M20 as the grade of the steel and concrete respectively. Grade of steel and concrete respectively. Now we'll go ahead with the step number 2, that is the effective span calculation. So this is again we need to go with the clause 22.2, that is page number 34. So this is the clause number 22.2. and this is for the effective span, and it is for the simply supported beam or slab. So what does that say? The effective span of the member that is not built integrally with its support shall be taken as clear span plus the effective depth of the slab or beam or center of support, whichever is less. So out of these 2 points, whichever is less, we'll have to consider that as the effective span. So I can write down here that as per clause 22.2a, page 34 of IS 456 2000, so we'll be going through the first one, that is clear span plus D, and for that we first of all need clear span. So clear span would be equals to now, so if you just look at the diagram, clear span would be this one as your clear span. So you need to just deduct 300 mm brick thick wall from the 8 meter, so that would be 7.7 meter. So clear span would be equals to, so if we just convert in terms of mm, so 8000 minus 300, which is equals to 7700 mm. And let us assume that effective depth, which is equals to 400 mm. In that case, you will get this clear span plus D, that is 7700 plus 400, which is equals to 8100 mm. And the second part is the center to center distance. Between supports, and that is equals to already given center to center distance between support, that is 8 meter. So therefore that is, this would be equals to 8000 mm, and minimum of it is 8000 mm. That would be considered as L effective. So therefore this would be going to be 8000 mm. So that's is the step number 2, where we calculated the effective span according to the clause 22.2. Now we can just go ahead with the step number 3. That is percentage of steel reinforcement. So percentage of steel reinforcement so amount of reinforcement has to be, or let us say for the single reinforced beam, it has to be around 75% to 80% of the percentage of steel, which is the limiting carrying capacity, and that if we just considered for that, you just need to consider the different values. Let us say values of PT limited. This is actually for M20 and FE415. So if we just consider this value, so it is going to be PT limiting equals to 0.96. So 0.96, this is actually the table that we will be considering for the different grade of the steel and different grade of the concrete, and we will be directly considering that 0.96. If altogether this is the kind of grade of the steel or the grade of the concrete is there, in that case we can just directly consider it as 0.96. And Therefore, now you need to calculate this PT here. So to calculate PT, you know that this PT has to be 75% to 80% of PT limiting. Let us consider 75% of 0.96. So if we just calculate this value, we'll get it around 0.72 percentage. So that would be the reinforcement percentage. Reinforcement, you need to just put it into the beam. Okay, so we'll consider the next step in the next video.